Hello!
Hello, it's day 19. Welcome to my channel. Welcome back to my channel and welcome to our science advent calendar. It's 24 days of science experiments with us and Ro. Ro has the advent calendar over there.
Here it is, number 19. It's got an exciting looking picture on the front. They have clues on the front. I don't know what this clue means. What do you think?
Molecules.
I think you might be right.
It looks like a molecule. Today is called Salt, Ice, and Mountains.
Ooh.
And
Crunchy
inside
salt.
that is 20 grams of salt called sodium acetate. 20 whole grams of it. You will need most of it for the first experiment, but set aside a few grams for the end.
All right.
Okay.
Okay, what else do we need, Erica?
We need distilled water.
I have a little bit of distilled water in this bowl.
Perfect. The syringe from day 4.
Oh, yes.
Wonderful. Spoon.
Spoon.
Glass.
Glass, we're going to use this flask. Yes.
Plate. And a pot of water that we're going to use as a bain-marie.
Oh, we've got this hot water right here. I'll keep that over here by the fire.
Oh yes, keep
For the
it
time
warm.
Okay,
Okay, so
let's break this up till clumpy.
Oh yeah, break that up. And what we're gonna do first is dissolve approximately 15 grams of salt in distilled water. But we only need about exactly 1.5 milliliters of distilled water, because the mixing ratio of water to salt is 1 to 10.
What?
Yeah, so
That's wild.
for 1 part water, you need 10 parts salt.
Okay, so this is 20 grams. So if we put half a spoon onto the plate, that'll be the bit we're keeping aside.
Yep, sounds great.
And the rest of it into the cup.
Oh. Yeah, okay, so we can save this for after, right?
Yeah, we can just get to that, it's fine. Move this down just a touch so I can see the whole table, see what's happening. There we go.
Okay,
Alright, so we've got our spare.
Spare is there. So use the syringe to measure the 1.5 milliliters.
Okay.
Okay, got it.
That's, yep.
All right, so for the salt to dissolve properly, the water has to be warm. The
1.5.
warmer the water, the better. Or the better the sodium acetate dissolves.
Do we put it in now and then see if it dissolves or not?
Yeah, put it in, and then we're gonna put the water into the glass and heat it up in our.
So that's got the water in it, as you can see.
Dissolving.
Not dissolving, no, it's made a bit of it wet. See, it's made it a little soggy, but there's still quite a lot of salt in there.
I'm gonna not reach for that. That doesn't seem wise.
All right, so put the pot on the table, lid up.
Ooh.
Put that in the bain-marie. Bring this a little closer, so that we can feel like we're more involved in all of this. Yeah, just probably rest it in there for a minute. And
So once it
think
gets
about what else.
warm, it'll dissolve completely. You can also stir a little with a spoon. Do you want to stir while I?
Yeah, I can give it a stir.
All right. That whole batch, so
Still definitely solid.
as it gets warm, you'll see that whole batch of salt water, or salt, will dissolve into just that 1.5 milliliters of water. You kind of need to use both hands and stir and swirl it like at the same time. Oh, it looks like it's going.
It's certainly getting wetter.
I mean, we just took that pot off the stove, so it gave it a, heating things up takes a hot second. Hot second. And while Ro's giving it a stir, let me just tell you about solution salts and crystals. Because in the first experiment that we're doing right now, the sodium acetate is dissolved in the added water and forms its own crystallization water. At higher temperatures, this can work so well that the liquid looks like water. So if it gets really, really hot, you'll have no crystals at all. when the liquid cools down, you'll get what's called a supernaturated solution. At room temperature, it contains more salt than technically possible. Huh.
This is what happens in our little heating pads that you've got. I never knew about these. I think it was last year you showed me a little heating pad, which is basically a little plastic pad with liquid inside. And then you collect this little piece of metal that's inside it, and the whole thing, it goes hard.
Yeah, and it heats up.
And it gets really hot.
It's great for sore muscles.
It's the same stuff that's inside this right now. So this
it's going.
This is doing its...
It is like, it's getting mushy. Ooh.
I can't believe that this is so liquidy already. I'm going to try and get rid of all of those crystals.
Yeah, they're going. So, what we would expect is for the salt crystals to leave the fluid when it cools down. But there is some kind of ignition spark that would be needed to trigger that process. Such a state is called metastable. It's stable, but it lacks the energy to change, much like many of us during quarantine. The contact with the newly added salt crystals supplies the required energy to start the process. And the solution recrystallizes, which I've just gotten ahead of us a little bit, but anyway, my funny joke hopefully distracted you. All right, so it is a liquidy. Look at that. The crystals have dissolved. They're not like
1.5 grams of water.
Yeah, milliliters of water.
Yeah,
grams of sodium. Yeah, super cool. So that was part 1. Now we are gonna pop that guy in the fridge, let it cool off, and see what happens after that.
All right.
So it did not sit in the fridge as we had hoped. But that's all right. We've got her going in the microwave. She's gonna be liquidy. And then we're gonna just do experiment 2. And we're gonna see what happens.
We did get it nice and clear.
Yeah. But then in the fridge it
Try it in another glass.
Okay.
I think this is going to work.
Okay.
The problem with this stuff is the moment it has anything else going on, like if it gets a little grain of dirt in it, this way it needs distilled water. The moment there's anything in it, it sets off the chain reaction that we're hoping to demonstrate.
Right.
So if it's in the fridge and it's cooling down, it's supposed to, if it's in a perfect area with no other grains or anything, it should cool to a cool, clear liquid. But if there's any disturbance in there,
or even one tiny molecule hasn't dissolved,
yeah, then it ruins the rest of it.
You're so good at microwaves. I'm really proud of you.
In the meantime, I've got some cheese here to make.
Yeah, Rowan's making cheese. Very productive household here. Oh, put it in a little tiny glass. A shot glass of sodium acetate.
It's not going well.
No. You're right. That is. It's not. Look at this cloud we've made.
That's what happened when I evaporated the liquid that was in it. It's gone in a big fluffy piece.
I quite like that.
Alright, let's see if we can do this properly. Get all the salty bits. I think I need more water.
More distilled water. Alright.
So what we've found is every single time we've tried to cool it down, it starts crystallizing again. And this is because these crystals it'll only accept all this water at heat. Once it gets below where it should absorb all the crystals, and it starts solidifying immediately again. So what we're going to do is just try pouring it hot and see what happens.
Yeah, 'cause that's experiment 2.
Experiment 2 is following their instructions. This is experiment 3 because we're making it up now.
Right. But experiment 2 was to make kind of like the little iceberg that we made in the microwave. It's by pouring this over that. It's allegedly.
You want to pour or video?
Tradesies.
Okay.
All right. Check a little bit by.
Yeah, do just a little bit at a time. So we've got liquid in the glass. All right. Well, this is not at all what experiment 2 was supposed to be.
Or 3.
Or 3.
We have a nice little pile of salt gook.
Little gloob of gloob.
A glooby gloob.
Still quite warm. Shall we try again? Try and put the whole lot in?
The whole lot?
Yeah.
All right. Let's do it. Science. This is what happens. We do many experiments and we hope they work. Science.
Now that I've touched this a lot, would you mind checking if I can touch it?
It's fine. It doesn't say don't touch it. It does say let an adult do this part. So maybe that's our problem.
We didn't get an adult.
Yeah. All right, so that was distilled water from the beginning. Here we go. Ooh, all right.
That looks good. Let's put it in the fridge.
Yeah, that's nice and clear. Oh my gosh, here we go.
So we have a clear liquid in here, which contains all of those salty bits that want to be solid, but they haven't been tricked into thinking that they're still hot, even though they're cold. So the moment I pour it out, they should hit this stuff and start crystallizing again.
Whoa! You're making a tower!
Have a look inside as well, see what's happening in there.
Oh, wow.
See the catalyst.
The catalyst
But that
jumped.
reaction went all the way in, and went up in here before I'd had the chance to pour it all
Wow,
out.
and now you can't pour it.
Look at all those crystals. Look on the outside. You can see it's kind of sheets
That's
crystal.
so cool. Ooh, yeah. Oh, yeah, there it is. Wow. Yeah. And you made a little tower there.
Made a little tower.
You are like Elsa.
And look, that's quite firm too.
Oh, wow.
And it's hot. Feel this. Touch this. Pick it up.
Oh my gosh.
That's really hot.
Wow.
That's what happens.
It's a chemical
It
reaction.
requires a certain temperature for this to liquefy, and you trick it. So it's got all this energy bundled up inside it as it's liquid, and then once it realizes that it's been tricked into cooling down, it heats back up so that it can go back to solid state.
So cool. Oh, and hold on, I think the book
really
has
awesome.
some words for us.
This is really hot. Touch this bit. It just came from the fridge. It was cold, and put your thumb in there. That's,
Whoa, it's really
What is
hot.
that?
That's like, wow. Oh my goodness.
that's amazing.
I'm so glad we made that work in the end.
Yeah, me too.
Persistence is key
Persistence.
in science.
I can eat this, right?
Yeah.
It's just salt, isn't it?
Sure.
No.
In fact, sodium acetate is a type of salt that has a slight smell of vinegar. Its melting point is approximately 124 degrees Fahrenheit.
It does smell like vinegar.
Melting results in a supersaturated liquid which remains fluid even below its melting point. In order to prevent unintentional crystallization, the liquid has to be stored in a clean and smooth container. And
Smooth container.
clean and smooth container. Interestingly, that you should mention my little hand warmers because the iceberg that we made is white but far from cold, as you just found out.
Yeah, it's a hot berg.
Yeah, it's a hot berg. This is because the recrystallization process releases heat, to be precise, exactly as much as you heated it up when you liquefied the salt the first time. Fascinating.
Which was quite a lot.
Right? The liquid has stored the energy of the heat. The amount of heat released during the recrystallization can be tremendous. Incidentally, this basically is how hand warmers work. They also contain sodium acetate.
Yay!
Yay, fun! Oh my goodness.
Day 19.
19, what a journey today was. Thank you so much for joining us for day 19. Only a few more days. And give us a thumbs up, a subscribe, share with your friends, leave me a comment, let me know what you think and how you are doing this December. And I will see you tomorrow. We will see you tomorrow.